Now let's see on how we can be able to evaluate the double integral as we have been given here using the Reimann sum, where the interval along x is given as 0 to 4 and along y is given as -1 to 2, and with the sample points given as a 3, and for the x and also for the y as well. Those are the sample points, and along x and also along y. Using the Reimann sum, how should we have it? First of all, we should have to use the points on the lower left corner, and secondly we use the midpoint rule, and thirdly we use the points on the upper right corner points. So that is, here we go. First of all we should have to use, we're looking for the volume, and let's have the lower left corner points, that is the volume, by considering the lower left corner points. So have it as V subscript L, and that will be given as the summation of the actually sample points along x, from sample point 1 to sample point 3, and also the summation of sample points along y, that is given as the j, starting from 1 to n as being given as 3, and of the function of xi, meaning the x values will be varying, and also yj, meaning the y values will be varying times dA. So that is the formula on how we should have it. Then we should have to calculate the value of dA. What is the value of dA? The dA is given as dy and the times dx. That is the value of dA. Then what is dy? The dy is given as, along y the interval ranges from -1 to +2. Then we have 2 minus 1 divided by the number of the number of sample points, that is given as 3. And by the way, you should have to understand that the delta, let's say, should be that of delta y. The formula has to be b minus a divided by in this case divided by a, where a is the upper value on the interval. It should be where b is the upper value on the interval and a is the lower value on the interval, of which minus it's part of the formula. You just have to subtract the 2. So in this case, this negative represents the general principle behind. So keep that in mind. So in this case, we'll have delta y being given as, have 3, we'll have 2 minus 1, that is 3, divided by 3 is given as 1. So that is delta a. Then now we should have delta x. So what is the delta x? We'll have it as 4 minus L, divided by 3. That will be given as 4 over 3. That is the value of delta x. Then it means the delta y should be dy, or the same as the delta y. Actually, it should be delta a. Delta a, which is the same as dA, will be given as, have it as 1 times, should be 1 times 4 over 3. That is the same as 4 over 3. So that is the value of dA in that way. So keep that in mind. That is the value of dA. So let me keep things off here. So the value of dA has been given as 4 over 3. Then now we're going to find the sample points, independently, and for x as well as the y. So let's go for x. Sample active points for x. So since we are taking the samples to be lower left corner, then the formula for the sample points is given as xi is equal to a plus, and that should be I minus 1 times delta should be times dx. So that is the formula, where a is the lower value in the interval along x, and where I is the variable in which it represents the variable for x, where it would be actually a value in the dx, it is the value, and the dx it is actually, in the dx it is the value of, and the dx is given as, we had it as dx as 4/3. So keep that in mind. So in this case, let's start with x1. Should be x1. So in this case, x1 will be given as, have it as 0 plus 1 minus 1 times delta actual x, which is 4/3. So in this case, we'll have it as 0. That is x1. And how about x2? We'll have it as 0 plus 2 minus 1, that is times 4/3. And what would be that? We'll have it as 4/3. And until we reaches at x3. So x3 is given as 0 plus 3 minus 1 times 4/3. So in this case, we'll have it as, and that should be 8/3. So since we're looking for, since the sum points has to be 3, that means we'll stop there. So in this case, let me really highlight them here. So x1 is given as, should be 0, and x2 should be given as, that is 4/3, and x3 should be given as 8/3. So in that way, you have obtained the sample actually a points, that is for x. Then I wish to have the sample points for actually y. So one thing with lefty actually lower corners is that if you think of having x4, then you'll be at 4. Just a single step, you'll be at 4. But we are not aiming reaching at 4, because we are already having actually 3 sample points as being instructed. But just a single step after that one, you reach to the actually upper value in the given interval. Don't try that. You happen to have it as 4. That is. And also for y as well, the principle will be the same. Yj, and that should be yj will be given as a plus j minus 1 times delta y. Formula will be the same. So in this case, y1 will be given as, have -1 plus, that is 1 minus 1 times delta y. What is the delta y? We had it as 1, so have that one. So that is the same as -1. And how about y2? So y2 will be given as, -1 plus 2 minus 1 times 1. And that is the same as 0, as you can see. And how about y3? Y3 will be given as -1 plus 3 minus 1 times 1. And that is the same as, and that should be 1. So we are to stop here, because we are recommended to have only 3 sample points. So let me have them here. So y1 will be given as, should be -1, and y2 will be given as, and that should be 0, and y3, and that should be given as the +1. But as you can see, just a single step from here. Let's say y4 will happen to have 2 here. So that's the principle behind the aspect of the lefty. Should be lefty lower corner points. So basically, for the lefty actual points, we don't really need to recharge the upper value on the interval, but just a single step from that one, you have to reach at the point. Then we should have to combine these actual sample points. So how should we combine them? So in this case, we'll have f of x1 comma actually y1, and that is, and now we'll be varying the y values while actually x value will be constant. So have x1 comma y2 until the y values are being exhausted. So have f of x1 comma y3. As you can see, the y values has been finished. Then we'll start again. Now we'll be changing the actual x value. So have f of x2. Now the y values will be changing. So f of x2 y2 until the y values are being exhausted. And also the same way we'll have f of x3. It should be f of x2 as well. F of x2 comma y3, like that. Then we'll change the x value. We'll have x3, that is y1 and x3, y2 and f of x3 y3. So since the x values are being finished, it means that's the end of the combination. So that's the simple way on how you can have it in that actual way. That is the simple way on how you can have it that way. And had it been that we had on, let's say x1 and x2, and we had, let's say, y1 and y2, what could be the combination? Principle means the same. You can have, let's say, x1 y1 x1 y2. So y values, so in this case the y values will be changing while the x value remains the same until the y values are being finished. Then we change the x value as well. So you could have x2 y1 x2 y2 in that way. So that could be the combination if that was the case. So with that one, try to have the combination of the following variables. If that could be the case, try to have the combination of the following at your own time. Let's say if we have m1 m2 m3, and let's say we have it as, let's say, q1 q2 q3 and let's say q4. Try to have the combination of these. And also, let's say we have, should be p1 p2 p3 p4 p5, and you should have to combine that one with x1 x2 and x3. How should you combine those? Try to express those, and I want to have the responses in the comment section below if that really works on, but you get it right. So that's how you should have to understand about the combination of those actually values. Now in this case, you have to substitute, you should have to substitute this in the given function. By the way, this is the given function. So where is that function? So I've removed it here. Basically, the given function was f of x y is equal and that should be 1 minus xy square. So you have to substitute these pairs into the function. So it means, for instance, for actually, for x1, y1, it means we have what is x1, that is given as 0, my y1, which is given as the -1. So we have to substitute for x here and for y here. Then you evaluate that one. So what do you think could be that one? So x0, it means the whole of this one will be given as 1. That is f of x, f of 0, -1. And also do the same with this pair and also this pair, and you finish them all. Then from there, you now have, you have to substitute into the formula, where you have the volume, checking the left corner points being given as, now you have to substitute for dA. What is the dA? We have it as 4/3, and it times the combination of the values you obtained here. So you have the summation of these values you obtained here, and then you have to cross it here. So that will be the volume in that way. So keep that in mind. So please take note of the procedures that are being followed. That's the principle behind. And now let's use the midpoint. Let's use the midpoints. Let's use the sample points as the midpoints. And how should you have it? Now, principle remains the same. On the midpoint, using the midpoint rule, principle remains the same. On the midpoint, principle remains the same. Only that now we'll have to evaluate the volume considering the midpoints in that way. And also here we'll have it as x bar and y bar, showing that we are considering the midpoints in that way. But everything remains the same until you have to calculate the dA. The value of the dA will be the same. And now what will differ is that instead of having x3, we'll be now having x4. And to make sure that we reaches at the max, we reaches as the upper value on the given interval of x. And also likewise, and for the y values, we'll make sure that we reaches at the upper value in the interval of x. So in this case we'll have, let me just have to take them out first. So I was saying you have it in the same way. We'll calculate, this is B by the way. So this is B, where we are dividing the volume using the midpoint rule. So in this case we'll have to calculate the dA. So dA is the same as dx times dy, and of which dx has been given as 4/3, and the dy has already been given as 1. You can remember that. And the dx will now be given as, I should say, dA will now be given as 4/3. That is. And now for x, should be dA here, not dy. What's that? Should be dA. That is 4/3. We'll keep it here. dA is given as 4/3, using the same way. Then I'll be calculating the sample points for x, using the same way for x. Use the same formula. We'll calculate the sample points using the same formula we discussed before. X is given as a plus I minus 1 times dx. So in this case, we already calculated that x1 is given as 0 and x2 was given as 4 over 3 and x3 is given as should be 8 over 3. Now we are not to stop here. We are to stop where we have to get the upper value on the interval of x. So which means we are to go for x4. You see that the x4 can be given as, that is x4 can be given as 0 plus 4 minus, and that should be 1 times 4 over 3. And that could be given as actually that can be given as going to be that of, that should be 4. So that's how we should have it there. Then let me present them here. So which means we have x1, we have x2, we have x3, and we have x4. That is for x. Then we should have to present those on the number line, and that to generate the actual midpoints. We should have to present those on the number line and to generate the midpoints. Now have the number line. This is for x1, for x2, for x3, and let's say for x4. So these are the midpoints that we are looking for. And now this is x1 bar, this is x2 bar, and this is x3 bar. So how do you find these actual midpoints? So for x1 bar is given as 1, actually x1 plus x2 divided by 2 will have this. And the x2 plus x3 divided by 2 will have that. And likewise that one will be the same as well. Then you have them as x bar 1 somewhere, x bar 2 somewhere, and x bar 3 somewhere. You have that. You also do the same with the actual y, where you'll be calculating the y sample points. Should be sample values. You also do the same for y, or have y1 that is being given as -1, y2 that was being given as 0, and y3 that was being given as 1. And I'll also be reaching at actually y4 in order to have the upper value in the given interval. That would be given as 2. Even as you can try using the same formula for the actually ij being given as, and there should be a plus j minus 1 times delta should be y, using the same way. So on the midpoint case, to generate the sample points, we use the same way we discussed about the left. So should be that. Then you present this on the number line as well, where you generate what is y1 bar, and what is y2 bar, and what is y3 bar. You do the same. Then you combine these actually sub-intervals and have it in the same way. That is volume using the midpoint will be given as delta, which is given as 3 over 4, and times the combination of whatever you have upon having, let's say, f of x1 bar, f of actually comma y1 bar. Also do the same with, you also have f of x1 bar comma f of x2 bar, and continues the same way we discussed about the left endpoints. Then you should have to combine them here. Then you multiply that one that way. That's how you'll be having it that way. So keep that in mind. So next video will be about the light upper corner points, and you appreciate how we can have it. Thank you.